Hello, my name is Bill Jones. I'm a construction management major here at EWU. Today I'm going to talk to you about permeable concrete and its possible answer to site development. One of the problems with site impact has to do with not only just the site itself, but all of the all of the parts that make up the site, the building, the sidewalks, everything like that. And to relate it to manufacturing, what I'm going to do is talk about the parking lots involved. Entire section of the Green Building Codes deals with the effects that the project will have on the natural water recovery and distribution systems. Like I said, the site impact includes not only the building imprint, but the parking lots, the sidewalks, roadways, and the accesses in and out of the property. Originally, before the project was taken in, the natural environment had found a way to filter all of the rainwater that came down, to filter out all the pollutants and contaminants before it returned it to the water table. Most of the conventional systems, they reduce these filtration areas and force large, huge amounts of waters into very small areas. And that water is required to go back through the small area and return to the water table. And it can affect not only the site that is being impacted, but also neighboring sites. As the water table is changed, so do your well heights and things like that. Most of your standard solutions are very expensive. To put in drainage swells, some projects become so expensive that the feasibility of the project has to be completely looked at again. The reason that some of the expenses are there is because it's highly regulated by the government. The reason for that is because of all of the components that are involved or will come into contact with the project. We're talking about water tables, natural environments, people, vehicles. All of these things come into contact with the project, so therefore the government needs to regulate that so that we as consumers aren't getting polluted. Also, many of the sites impacts involve more than 50% of the property involved. If you think about like a Walmart as an example, I would say on the average probably 90% of the property of a Walmart site is taken up by either the parking lots, sidewalks, accesses, or the building. Very little of that property is left to natural habitation. What little bit is usually left there are the drainage swells, which are put into place. Most of these solutions create an umbrella that covers the entire site. Like I said, it forces all of the water into a concentrated small sector of the project. Previously, the entire project or the entire property had been able to filter all of this water down so that it could properly filter it before it returns to the water table where we pull it back out and consume it. Also, most solutions take up very valuable parking areas, especially in manufacturing. In manufacturing sites, there's three things that they want to deal with. They want to deal with how can we build it, which would be your building, how can we get our people here to take care of it, which is your parking, and how can we deliver it, which is your roadways and accesses. Permeable concrete is on the leading edge of green technology. The cost is much more effective. Like the two pictures here show, conventional concrete becomes very, very solid. The way that you make permeable concrete is you take less water and put it into the concrete mix, and you omit all of the fines. What the fines in the water do is they allow the concrete to mix into a solid form. Without having those, as you can see here, we've got air pockets that develop in the pervious concrete. Those air pockets are what allow the percolation of the water to return to the ground and to take out all the pollutants. The water returns to the underground water table much more naturally over the entire site if your parking and your walking areas are done with permeable concrete. If you could take a moment and think about it, if you took all of the Walmart parking lot or a manufacturing site parking lot, either way, and you take all that water and you try and funnel it through a funnel, it's going to take a really huge funnel to hold all that water, and it's going to take a really long time for that water to come through that funnel. Well, if you take the same exact amount of water and you place it over a fabric, now that water can go through it very much faster, and it'll also filter out those pollutants better. And that's basically what permeable concrete does. It acts as a drain field. It pulls all the pollutants and fine particles out of the rainwater. The quality of the water returned to the water table is actually better for the environment as well. Of course, with every Wonder product, there are drawbacks. Two of the biggest drawbacks are the inability to take concentrated loads, and the ability to resist repetitive impacts is very low. Like in a roadway. As an example, our overpass out on the I-90 over-ramp. Anytime you have a variance in load that is going across and hitting something, you're going to have a variance in impact. Well, if you have a truck that's running at 95,000 and a person's minivan that's running at 5,000, there's big impact differences when they hit those things. They have been working on this in California, and last year they actually built a road that's in use today that's being studied to see what the feasibility of making all roadways, at least in the lower 48s, out of this. The other drawback is, of course, freezing conditions. Anytime that you take water and you try and filter it through something and it freezes, it expands. They've actually been working with this in Minnesota to overcome this. What they're finding is if they leave bigger air voids, the water is able to actually drain down through the concrete at a faster rate. By doing that, the water is not allowed to be trapped in the concrete, so it doesn't expand and break it. Snow removal is the biggest difference when it comes to clearing a parking lot. Conventionally, you're going to use a steel snow plow with a steel bit on the bottom of it, so that as it goes across the concrete, it'll pick up as much as you possibly can to get rid of it. With regular concrete, you have a very smooth surface, so you don't have to worry about the blade digging in and breaking anything. When you start dealing with pervious concrete, what you have to do is put a rubber or plastic bit on the bottom of the blade, push it up and allow it to melt. Possible future uses, like I said, are highways and roadways. Eliminate hydroplaning because the puddles would not be able to build up on the roads. It would also reduce the need for wastewater management. It would change it from the fact of being a constant use to only having to be used in cases of emergencies with flooding, flash rain patches, things like that. And it also lessens the carbon imprint. Here's a short video to show the effectiveness. As this concrete truck is dumping approximately 2,000 gallons of water, you can see that the effective area is approximately 15 feet by 15 feet. Now, if you were to pour this onto concrete, this would be a puddle that would last forever and ever and ever. I mean, it would never go through the concrete. But as you can see, it can definitely absorb that. As it's absorbing it, it's pulling all those pollutants out. It's making the water actually better to return to the aquifer. Go to the next one. And here are the sites that I went to pick up some of my information. There are definitely sites out there that can give you some more of the technical data. One of the things that I found very interesting has to do with the advancements in the load-bearing capacity. They have gotten it to the point now where they can load between 500 and 4,000 pounds per square inch. So they're definitely on the rise. It's an up-and-coming product that is definitely getting ready to be used all over the place. I'd like to thank you for your time today. Are there any questions? Yeah.
I know that going green is the thing that we're supposed to do, but normally the reason why people don't is because it costs a lot more money. So what's the cost of this concrete as opposed to like regular concrete?
Actually, the cost is, depending on the design, The cost is usually less. For one, your concrete cost is less. Your finishing is much less. You don't finish it conventionally like you would normally with concrete. They're actually using a compactor on it. Your reinforcements have to be a little bit stronger, but I think the value and savings in the concrete, in addition to the design costs, because those drainage swells are not cheap in any way, shape, or form, either to design or to install or to maintain. So the cost effectiveness is definitely there with the permeable concrete.
I was wondering about like ice melt chemicals and stuff.
Yeah, that's the other thing. When you're dealing with it in frozen areas, there are only a few chemicals that you can use on it, and you definitely don't want to use sand on it. The reason for that is, if it's just like anything else, if you put a sealing surface over the top of it, nothing's allowed to percolate through it. So the cleanup during the winter is a lot different. You use a vacuum, basically. These lot sweepers and vacuumers, they use those to clean the lot. And then another thing that they use is they actually use a lot of water to clean it. They'll go in and they'll actually spray it, and then they'll pump water through it to get those pollutants to pull through.
This is on a freeway, would they just vacuum it a couple times a year?
That's a good question. Actually, I think what they would probably do is they would probably have a truck with high water jets go across it and blow it off with water.
Yeah, I was wondering with the high pressure, if that would just get small particles further into it and really, you know, it just clog
If you
it.
used an aeration in with it, I think that the water jet combined with the air would pull it out. There's actually one place here in Spokane where they've used permeable concrete. It's at Liberty Park. It was used for a trail. It's the only place in Spokane that I personally know of that it's been used. But you can go and actually look at that concrete versus all the rest of the concrete. That concrete has no cracks in it. Every other sidewalk in that park has a crack in it. So there's definitely some drainage advantages to it. Any other questions? Dan?
Are there areas of the country where you're more likely to see this kind of thing than you are here?
I would say the lower 48, probably the lower 2/3 of the lower 48 states. They are using it, like I said, in Minnesota. They're working on applications up in Alaska, actually, to where they're going to try and see what extreme colds will do to it. Because as with any concrete, there's going to be a certain amount of moisture left in it, and since the water flows through it, it's going to inherently keep that moisture. If you take that down to 30 degrees below zero, I think that's why they're testing it in Alaska now, to see what those extremes will do, what California does. Now let's try and work towards, you know, the upper half of the 48 states to get it so we can use it here.
Is this a pretty big thing in California?
Most of the research that I found was either in California or over in the Orients. They're using it quite a bit in the Orients. Any other questions? Joe?
I don't know, it seems like the biggest challenge when it comes to impact strength is that you got a relatively low contact area between the particles. So do you find that it's, when trying to improve the impact strength, is it harder to kind of increase the strength of the material or the adhesive holding the particles together?
I believe that it has more to do with the adhesiveness. Another factor that has to do with the bearing ability has to do with the subgrade. The higher your subgrade is, the higher your compaction rating can be. They use polymers and other things to add into it to try and raise that up, I noticed in some of the research I looked at. Anything else?
Yeah. Do you know of any impact on tire wear, or if it breaks down more than normal concrete?
I don't know the exact answer, but I will venture to give you my opinion. Locally here in the state of Washington, we have rumble strips. Now, as you can imagine, a rumble strip is 13 inches wide and 4 inches in diameter. If our tires can go over that at 70 miles an hour, I think they could probably go over repeated holes about the size of a marble. So I don't think that the impact on the tires would be any more than where we are right now, at least in our state, because of, you know, like our rumble strips. Our asphalt here breaks down very fast, so our roadways become very rough very fast. The pathway down at Liberty Park, it's been there for years. It is smoother than the concrete that they just did on Sunset Hill. Because I've actually broke down on Sunset Hill, so I know how rough that is to get out of there. So, I mean, a lot of that also has to do with the way that it's installed, the way it's designed. Some of the designs did call for a small portion of fines. Most of them called for very, very, you know, 0 fines basically, but there were a few that called for small amounts of fines. So I think those applications might be able to get us a little smoother surface, but not change our porosity. Is there anything else?
Thank you very much.
Yeah.